May 2025, time zone 1, ChemSL paper, 1A. Okay, question 1, pretty nice and straightforward. So the diagram below shows the behavior of protons, neutrons, and electrons in an electric field. What is the correct identity of each particle? First, we can take a look at the one that's undeflected. Well, we know that Y is undeflected, so it's going to have no charge because anything with charge is going to be affected by the electrodes. So that's going to be a neutron, so we can eliminate A and B. And then we'll see that X is deflected in the direction of the positive electrode, so it's got to be a negative charge, and it's got to be an electron. So the answer choice is C. Next, which of the following species has the same number of outer electrons? The letters do not represent symbols of elements. Okay, so W would originally have 12 electrons in the neutral state, but now it's got a 2+ charge. So in that case, it's going to have 2 less electrons than 12, so it's going to have 10 electrons. X would originally have 16 electrons in the neutral state, but it's going to have 1 extra electron, so it's going to have 17. And in a similar process, we can see that it would have had 21, but it's got 2 less, so it's going to have 19. And it would have had 9, but it's got 1 more, so it's going to be 10. So the ones that match up are Z and W. Which diagram shows the correct electron configuration of a nitrogen atom in the ground state? Okay, so nitrogen is going to have 7 valence electrons. And so the first thing we have to do is fill in the S block. So C is not filled in, so that can be ruled out. D has too many electrons, that's going to be 8 electrons. That's ruled out. Now, the difference between A and B is how they fill in the P block. And when we're filling in 3 electrons in the P block, we have to fill them in one at a time. So we have to go evenly. So now the answer choice is not B, and it's going to be A. Which row shows a gas that would deviate the least from ideal gas behavior? Okay, so the conditions in which, for pressure and temperature, where a real gas approximates an ideal gas is going to be high temperature and low pressure. So immediately we can rule out C and D. Now, one of the assumptions for an ideal gas is that there are no intermolecular forces. And taking a look at these two, then we know that ammonia is going to have hydrogen bonding, which is the strongest intermolecular force. Remember that that's going to be when anytime an H is bonded directly to an N, O, or F. So in that case, then ammonia is going to have quite strong intermolecular forces, which violates one of our assumptions for an ideal gas. So we know it's not B and it's going to be A. Which row correctly shows the shape of an S and P block atomic orbital? Well, IB is only ever going to ask you about S and P. They're not going to ask you about D and F. And so you can just memorize the shape. S is going to be a sphere and P is going to be like one of these shapes. And note that because P is only symmetrical in one dimension, as in like, you have this, and you're going to have the other one going this way, and then the last one going that way. Then you need 3 of them, which is exactly what we expect. 6. The volume of a container filled with a fixed amount of gas is increased by 100% at constant temperature. How does this affect the pressure in the container? PV equals nRT. Okay, so T is constant because constant temperature. R is a constant 8.31, and N is also constant because it's a fixed amount of gas. So we originally have PV is equal to a constant, which doesn't change as we do things. Now, the volume is increased by 100%, which means that it's doubled. So if volume is turning into 2V, then how do we make this equate to the same constant? Well, then we have to half the value of P, because this 1/2 and the 2 will cancel each other out. And what is an analogous situation to having the value of the pressure? Well, it's decreasing the pressure by 50%. Can't decrease it by 100%. That just means taking it all away. Which row shows the correct formula and electron configuration for the species in calcium nitride? Okay, well, calcium is going to have that +2 charge, and nitride is going to have that 3-. So in order to join them together, then we know that it's going to be Ca3 and 2. So we can rule out A and B. Now this is ionic bonding because of the high difference in terms of their electronegativity values. So what is ionic bonding? Well, it's going to be the electrostatic attraction between a cation and an anion. And remember, in these situations, then the cation is going to have completely donated all of its valence electrons to the anion. And in that case, okay, so then if all of the valence electrons have been donated from the cation, then it's going to resemble a no-go gas in that it's going to have 0 valence electrons. And in a similar fashion, if the valence electron shell of the nitrogen has been completely filled by taking in the donated electrons from the Ca, then it's also going to resemble a noble gas, as in it's going to have a full valence electron shell. And so the only situation where we see that is going to be in answer choice D. Diagrams of 4 stable allotropes of carbon are shown, which row correctly identifies each structure. We start with W. We know that every single carbon in W seems to be bonded to 3 or 4 other carbons, and it's in a tetrahedral structure. So that would mean that it's going to be diamond. So we know that it's here. And indeed, that's kind of enough information to figure out that it's A, but we'll keep going. X, we can see that there are layers, and every single carbon is trigonoplanar bonded to trigonoplanar bonded to 3 other carbons. And because there are multiple sheets, then we know that it's going to be graphite. Buckminster fullerene is a ball. And Z, which is graphene, is going to be a single sheet of graphite. So it's still trigonoplanar, it's just one of these thin sheets. And so all of them line up with answer choice A. In which of the following molecules do all atoms obey the octet rule? In general for our course, the only things that are going to violate the octet rule are these ones, B, BE, and AL. And they're going to violate it because they're going to form less bonds than we otherwise would expect. So based on these answer choices, then we can just eliminate this one, and that's enough to solve our answer. So it's going to be B. Which compound has the weakest ionic bond? Okay, so the strength of an ionic bond, okay, so remember that the definition of an ionic bond is the electrostatic attraction between an anion and a cation. So we're really talking about how strong is that force of attraction between that anion and the cation. And in this question, we're doing a comparison between Mg and Ca and S and O. Well, consider this. So we know that electrostatic attraction is going to decrease as we move things further apart. So if 2 charged objects are far apart from each other, then that force is going to be reduced. So for something to be weak, then we want them to be far apart, as in the species in the bond are going to be as large as possible. That way we can space out the nucleus and the nucleus. So we're looking for 2 of the larger elements or atoms between Mg and Ca and S and O. And if we look, Ca is larger than Mg, S is larger than O. So it's going to be Ca and S. Which row puts each of these molecules in order of decreasing bond angle? So let's go through and draw them all. CH4 is going to be a C surrounded by 4 of these guys. That's going to be tetrahedral. And so then that's going to be 109.5 degrees. Ammonia or NH3 is going to look like this. That's going to be trigonopyramidal, and that's going to be 107 degrees. H2O is going to look like this. That's going to be bent with 4 electron groups, and that's going to be a 104.5. And the last one, C2H4, is going to look like this. And those are going to be trigonoplanar and nearly 120 apart from this double bond. So in order of decreasing bond angle, then it would go 120 and this way. So it would be answer choice C. The following thin layer chromatogram was obtained from a mixture of naphthalene and naphthol. A polar silica was used as the stationary phase and a nonpolar hexane as the mobile phase. What is the position and RF value of a naphthalene? Okay, so the mobile phase is the one where we kind of see the spots traveling up the sheet of the paper. Now we use a nonpolar hexane in the mobile phase, and we have to distinguish between X and Y. So we know that polar things are going to, or sorry, did I say polar? We use a nonpolar hexane as the mobile phase. So something nonpolar will dissolve better in nonpolar and travel further. And likewise, something polar will dissolve better in polar and travel further. But in this situation, we have a nonpolar. So the nonpolar one is going to travel further and be spot X. And we can, between these two, we realize that naphthol is going to be polar because of that extra oxygen, and naphthalene is nice and symmetrical and it's going to be nonpolar. So we know that naphthalene is going to be X because it has better solubility in the mobile phase. Calculating RF value, remember that we have to start from the baseline and not the edge of the paper. So the solvent fund has traveled 5 units and X has traveled 4 units. So it's 0.8 and it's going to be X. Okay, aluminum trichloride and beryllium chloride have been known for many years. Which adaptation of the bonding model was made to explain their bonding? Well, remember earlier when we talked about the exceptions to the octet rule, we did bring up these ones. And it turns out that, they are exactly the ones where we have the exception to the octet rule. Germanium has several stable oxidation states. Which row shows these species in order of increasing radius? Okay, well, germanium, these are all going to have the same atomic number and hence the same number of protons and hence the same amount of positive charge in the nucleus. And in that case, if they have the same number of positive charge in the nucleus, then the size of the radius is going to depend entirely on the number of electrons. Okay, and we can see here that they are all different number of electrons. The thing with having more electrons and the same number of protons is that the extra electrons that you're going to add are going to cause extra repelling forces to appear between the electron and the electron. So as you add more, those repelling forces are going to spread the electron cloud out under the same number of protons. And so adding more electrons to this situation will cause a higher atomic radii. So in that situation, then, in order of increasing radius, we want to start with the lowest one, and that's going to be the situation with the least number of electrons, and that's going to be the 4+, right? And then it's going to go down like this. So it's going to be A. Which statement explains the trend in first ionization energy from sodium to chloride? We're going to ignore the effect of having half full and full orbitals in this situation because that's not a general trend. That's just kind of specific situations where it kind of goes down a little bit. And this is going to be also somewhat related to the atomic radii trend. So the fact is that as you increase the number of protons, so as you increase the atomic number, which is what happens as you go right from sodium to chloride or chlorine, then you're going to increase the strength of the electrostatic force between the positive nuclei and the electrons on the outside. So really the strength of that bond depends mostly on the protons in the nucleus. So remember the previous situation where we had the same number of protons throughout the entire time, and now we're actually increasing the number of protons as we move to the right. So that's going to be the most directly responsible because that also increases the effective charge in the position of the electrons, right? So really what it is going to be the nuclear charge increasing that is going to cause the trend in the first ionization energy. It's not going to be atomic radius because that's kind of a side product. It's a nuclear charge that causes the atomic radius too. So kind of the one cause, two different situations. Electronegativity doesn't have an effect on first ionization energy. And shielding is actually going not to increase because shielding depends on just the ring before it. So shielding has nothing to do with the valence shell. It's going to have everything to do with the shells beneath the valence shell. Which elements would react with each other most vigorously? Well, in general terms, we can think of these as going to be the metals, and these are going to be the nonmetals, so this is ionic bonding. So basically, we're looking for things that are most willing to give up their electron and most willing to accept an electron. So comparing K and Na, K is going to be larger. So the larger atom is going to hold on to that electron, the lone electron, less, right? Because it's further away from the nucleus and distance affects electrostatic attraction by making it weaker. So K is more willing to give up that electron, making it more reactive. On the other side, we want something that is most ready to accept an electron. And between Br and Cl, well, Cl is going to be smaller. So the force of attraction from the nucleus to that position is going to be stronger, and so it's more willing to take in that electron. And in that case, we know that K is most willing to give it up, and Cl is the most willing to take it in. And so we know that the answer choice is B. Ammonia and nitrous acid are compounds of nitrogen. What are the oxidation states? Okay, well, H is always going to be a +1. And remember, this is a neutral overall, so that we know that the N has to cancel out 3 of the H's. So the total effect of the 3 H's is going to be a +3, so N has to be a -3. So we can rule out A and C. Actually, I'm going to cross out. Now, H is a +1, and we should know that N is going to be, or O is typically going to be a -2. And again, we have to get to 0. So this would be minus 4 because there's 2 of them. Plus 1 makes minus 3. So the n has to be the plus 3, and that would even it out. That's D. Consider a reaction that is in thermal equilibrium with the surroundings. When a reaction takes place, the temperature of the mixture decreases. Okay, so the mixture really is the surroundings of the system. Because like you have a specific reaction that's taking place inside the mixture, and the mixture is taking the form of the surroundings for this particular system. So if the temperature of the mixture decreases, that means the temperature of the energy of the surrounding is decreasing. It's kind of like doing your reaction in water. The water is your mixture, right? So we know that the energy is going to decrease. So that rules out this one because the temperature of the mixture decreases. If your water decreases when you do a reaction, then you know that it's got to be endothermic, right? So the temperature of the surroundings decreases. And in a similar vein, well, we know it's endothermic, so then we know that the answer choice is D because the energy of the system increases. Okay, we'll skip this one because I realized that this is kind of a long calculation one, so I'll write out the solution to this. 20. Chloroethane is produced by the reaction of ethane with chlorine. What is the atom economy for this reaction? Okay, so atom economy is going to be the total mass of everything that's going in. Oh, we know it says here. Okay, so, well, all reactants is going to be what? 30.08 plus 70.9. And then what do we want? Chloroethane is produced. Well, that's going to be this one, C2H5. So that's 64.52. And what is that going to be? Well, that's going to be C. 75 cubic centimeters of propane was completely combusted in 400 cubic centimeters of oxygen according to the following equation. What is the volume of unreacted oxygen remaining at the original conditions? Okay, so, well, this is going to be a long limiting excess calculation, but we'll do it. 75, okay, so this is going to be 0.075 liters of propane is going to cause, well, let's just say 22.7 liters. It doesn't really matter because in the same conditions, this number will all be the same and it'll cancel out. 1 mole, and we'll just go 1 mole and we'll convert it into, suppose we say, or no, we can convert it directly into oxygen. So oxygen is going to be 5. Or this is 1 mole of the thing. So this is going to be 1 mole and that's going to be 5 mole of oxygen. This is like propane. This is oxygen. And again, this is 1 mole and 22.7 liters. And if we convert this out, well, it's really just going to be 0.075 multiplied by 5, which is going to be 0.375. Right, so 0.375. And so the amount remaining is going to just be the difference between these two, and that's going to be 25. Consider the following maximum Boltzmann energy distribution at a certain temperature. What represents the distribution and value of activation energy at a lower temperature? Okay, so lower temperature doesn't affect activation energy because that's specific for a specific reaction. So the activation energy is going to remain at the same place. Now, for a lower temperature, remember that temperature and kinetic energy are kind of synonymous to each other. So if it's a lower temperature overall, then most particles are going to have less kinetic energy, and the curve is going to be up and to the left. So that's going to be A. The volume of gas produced in a kinetics experiment is plotted against time. What is the average rate of gas production for the first 20 seconds? So for the first 20 seconds, we get to here. And so average is going to be, 40 divided by 20. That's going to be 2. The following equilibrium was established. Which changes would shift the position of equilibrium furthest to the left? So this is going to be a endothermic reaction. So the Q is coming in on this side. So we want to shift the position of equilibrium furthest to the left. So first of all, well, actually, really, it's enough to analyze temperature. Temperature decreasing will push equilibrium to the left because of the Chatelier's principle. So you can think of Q as kind of being like a reactant. If you lower the amount of heat, then the system will shift left in order to try and produce more heat, right? So decrease is the answer here. And nominally, I guess it doesn't really matter what the pressure is because they have the same number of gas molecules on both sides. So that's going to be B just by looking at temperature. Which two species can both be Bronsted-Lowry acids and Bronsted-Lowry bases? So an acid is a proton donor and a base is a proton acceptor. So it's got to be able to accept and donate. Looking at this, well, this one can donate, but it can't accept. And this one can accept, but it can't donate. So not A. And we get one here where we can. So again, this one can't donate. And this one can't donate. So we know that the answer choice is going to be B. A solution has a pH of 3.0. What is the hydrogen ion concentration in the solution in moles per decimeter cubed? Well, just by the definition, right, then we know that the answer choice has to be B. Because really, well, pH is just telling you, it's like 10 to the minus what it's going to be. So like the concentration of H plus is going to be 10 to the minus pH, which is exactly B. A reactivity series of selected elements arranged from highest activity to lowest is shown. Which reaction is spontaneous? Okay, so let's just take a look. CD and PB. Well, CD is going to be above PD. Okay, so we note that this one is higher and this one's lower. Fe and Sn. Fe again is higher than Sn. Z and Cu. Well, Z is actually, okay, well, yeah, Z is higher than Cu. And, okay, so nickel and cobalt. Nickel is lower than cobalt. Okay, so just based on logic, then we know that the answer is D. Because 3 of them are the same and 1 of them is different. So it's got to be the one different one. Now, the way that you want to actually work this out in terms of, knowing the content is that, okay, the one that's higher is going to want to turn it into an ion most readily. And the one that's lower kind of doesn't really care. So the one that's higher is going to be the one that, if we have a neutral atom in the higher state, then it's going to have the most powerful effect in trying to turn into an ion. So if you notice that all of these guys are kind of lower, and these guys are already high up. So like these guys have already done what they want to do, as in turn into an ion. So something that's lower is not going to take away or not going to give them the electrons anymore. Okay, so the higher you are in the activity series, the more you want to turn into an ion. If you're already turned into an ion, then you're not going to do anything more. So these guys are higher, so it's impossible to make them do anything more. This guy is higher, so it's going to actually turn into an ion, and it's going to be able to do that because it's higher than the nickel. So that's D. Which alcohol in conditions would produce the highest yield of methyl propanoic acid? Okay, so propanoic acid is a carboxylic acid, and that's going to result, it's the two-step process from a primary alcohol. So we need to start with a primary alcohol and do reflux, because reflux is the experimental technique that allows us to do something twice. Okay, so which one is the primary alcohol? Well, 2-methyl prop-1-ol. That's going to be B. So distillation would be the one where you are oxidizing a secondary alcohol. And that's going to allow you to create an aldehyde. Which rule correctly shows heterolytic fission? Heterolytic fission means that one side gains both and the other side gains none. Right? In these situations, first of all, they should be drawn with a half arrow. And if it's one electron to both sides and they're the same afterwards, then it's going to be homolytic fission. So we know that's not these two. And you should be creating two things that are different. That's why it's heterolytic. So it's definitely not going to be D because you produce two of the same thing. So it's going to be C. The methanol fuel cell relies on the oxidation of methanol by oxygen. Two half equations are as followed. What is the balance equation for the overall reaction? Okay, so we want to balance, first of all, the number of electrons. So we multiply the top one by 2 and we multiply the bottom one by 3. And that way the electrons are gone. Okay, so then we can read across. So it's going to be 2 of these guys. That makes sense. And really that's like kind of enough to solve the problem. 3 oxygens, that makes sense. This 3 distributes to here. 2 CO2 on the other side, that's here, so that makes sense. And the 4H2O is going to be the direct subtraction. So this is going to be 2 waters, and that's going to be 6 waters because 3 times 2. And so 2 minus 6 is going to give the 4 on this side. So that's going to be A. Okay, so that's the whole thing except for that one problem.